Section 2.2 is all about subsets. We mentioned in the last video that even though a set cannot be an element of another set, a set can, however, potentially be a subset of another set. So we would say that set A is a subset of set B and expressed just like this. So there's actually two parts to the subset symbol. We have what looks like a squished C with an equals bar below it. So those two symbols combined make up the subset symbol. So we would say A is a subset of B simply if every element in set A is also an element in set B. Please note that the empty set is a subset of every set on the planet. So if you see everything in the set on the left, in the set on the right, we say it's a subset. Now, even though the order of the elements inside a set does not matter, it does matter the order of the sets around a subset symbol. So to show you what I mean by that, looking at example 1, we got A, B, C, D. The directions are the same. We're going to either use the subset symbol, or when you see the slash through it, that would mean not a subset symbol, so one or the other. It says write subset or not a subset in each blank so that the resulting statement is true. So starting with A, we're going to always start with the set on the left, the set that comes first. That's what I meant when I said a minute ago that order matters around the subset symbol. So I'm going to start with the set on the left, which is 1, 2, 5. And to be a subset, I better see all those numbers somewhere in the set on the right. So let's check. The first number is 1. Yep, here's 1 on the right. 2. Yep, 2 is somewhere in the set on the right. 5. Yep, 5 is somewhere on the set on the right, because the set on the right is 1 through 7. So 1, 2, 5, all those elements are in the other set. So yes, it's true that this is a subset. And as usual, that's a sad drawing on my part, but that's me trying to draw the squish C with the little underline below it. So we'd say the set of 1, 2, 5 is a subset of the set of 1, 2, 3, 4, 5, 6, 7. Let's try B. The set -3, 0, 3, and then the set on the right is -3, -1, 1, 3. So let's go again from left to right and see if all the elements on the left are somewhere on the right. So -3, yep, that's on the right. 0, nope. 0 is not anywhere to be found in the set on the right. So therefore, I don't have to go any further. This is not a subset. So I'm going to put the little slash through the subset symbol. Let me try to draw that again. There we go. So -3, 0, 3 is not a subset of -3, -1, 1, 3 because 0 is not an element of the other set. Remember, to be a subset, all of the objects, all of the answers better be somewhere in the set on the right. All right, looking at C, the set of X such that X is a dog, the set of X such that X is a purebred dog. Just like in the last video, when they give us that set builder notation, we only care about what comes after the bar. So the first set is talking about all dogs. It just says X is a dog. Whereas the set on the right is being more specific. It's talking about the purebred dogs. So putting it all together, if this were a subset, we would be saying that all dogs are purebred dogs. To be a subset, you can think of it as meaning it's contained in the other set. So are all the dogs on the planet purebred dogs. Well, that's obviously not true. Think about all the mutts out there. So this is not a subset. It's not true that all the dogs are purebred dogs. Now this is again why I say though that the order around the subset symbol matters. If I had switched this up, if I had the purebred dogs on the left and I had just normal dogs on the right, then it would be a true statement because all purebred dogs are a type of dog. But the order they presented us this particular question, it's not true. Because again, we got to go from left to right. So it's not true that every dog is a purebred dog. So it's not true that the set on the left is all contained in the set on the right. And then finally D, the empty set. Remember, the empty set is a subset of any set you can dream up. So that's going to be true. The empty set is a subset of the set of 2, 4, 6. I don't even have to read what's in the other set. As soon as I just saw a little squiggly set bracket on the right, I automatically know that's true. It's a subset of any set. Again, order matters. So what if they gave you the same question in the homework, but that set of 2, 4, 6 was on the left and the empty set was on the right? Well, then it wouldn't work out because the set of 2, 4, 6 is not contained in empty set. You don't see 2, 4, and 6 inside the empty set. So that's a false statement. So my point is that empty set has to be on the left of a subset symbol for you to say true, for that to work out. Let's try one more example. Example 2, same directions, write subset or not a subset in each blank so that the resulting statement is true. So we have the set of 2, 3, 7 this time on the left. On the right, so is that a subset of the set of 1, 2, 3, 4, 5, 6, 7? Remember, subset, don't overthink it. Is everything you see on the left somewhere on the right? Well, 2, yep, it's on the right. 3 is on the right. 7 is on the right. Yay! Order inside the set doesn't matter. Just what's around the subset that matters order-wise. So yes, this is a subset. The set of 2, 3, 7 is contained in the set of 1 through 7. So we're going to up the ante a little bit more here. So some subsets, you can take it a step further, and they're what's called a proper subset. So we would say that set A is a proper subset of set B, expressed as A is a proper subset of B, if set A is a subset of set B, and on top of that, sets A and B are not equal. To summarize, a proper subset is a subset where the sets are not the same. Please note the empty set is a proper subset of every set except itself. So let's put that all together. You'll notice the notation is very similar to a normal subset. If I look closer, I still see the squished C symbol, but no equals bar. So that's what proper means. Proper means not equal. We don't want the same set. We don't want matching elements. We don't want all of them to match anyway. So what I do, because proper subset can get a little tricky, is I make a criteria and I check each one very carefully when I get a question about proper subset. So there's pretty much just 2 criteria that we need to check. Proper subset is a type of subset. So the first question you're going to ask yourself is this a normal subset? Are all the items located somewhere in the set on the right? And then the proper part means the sets are not the same. So in other words, we want them to be different sets. So in order for you to say yes, that's a proper subset, it has to pass both this criteria. It has to be a subset, and they need to be different sets. If you say yes to both criteria, then you're going to say, yes, this is indeed a proper subset. If it fails either criteria, you're going to say, nope, it's not a proper subset. So we want a subset where the two sets are different sets. So they're going to ask us for both subset and proper subset in this one. So if I look at example 3, the directions for A through D says determine whether it's a subset, because it has the little equals line below the C. If it's a proper subset, where they take away the equals bar. If it's both, meaning both a subset and a proper subset, or neither, can be placed in each blank to form a true statement. So is it subset, proper, both, or none of the above? Okay, so let's start with A. The set of VCR, is it a subset of VCRS? Well, let's start with a normal subset. Is everything on the left, somewhere on the right? Well, V, yep. C, yep. R, yep. Everything in the set on the left is contained somewhere on the set on the right. So it is a normal subset. That works out. Okay, now let's check it to see, can we take it a step further? Is it not just a subset? Can we also say it's a proper subset? Well, let's check our criteria. First criteria, is it a normal subset? Well, we just said yes. Check. It's a normal subset because everything in the set on the left is somewhere within the set on the right. Criteria 2, are these two sets different sets? Yes. The set on the right has an extra element. It has an S in it. So it also passes criteria 2. So it's also a proper subset where I take away the equals bar because the set of VCR is a subset of VCRS and it's also a slightly different set. It's a different set. So it ends up being both subset and a proper subset. So they're both the correct answer. All right, let's try a few more of these. Taking a look at B, the set of 0, 2, 4, 6, 8 is on the left. On the right, the set of 8, 0, 6, 2, 4. Let's start with the easier one, which is just a normal subset to begin. So, is everything you see in the set on the left somewhere within the set on the right? Well, 0, yep, that's on the set on the right. 2, yep, that's inside the set on the right. 4, yep. 6, yep. 8, yep. So all the numbers you see on the left are somewhere within the set on the right. So it is a normal subset with the little equals bar below the C. Now let's check for the harder one. Now they want us to also check to see if it is a proper subset. So criteria 1, is it a normal subset? Yes, we just said that a minute ago. The set on the left is a normal subset of what's on the right. Criteria 2, are they different sets though? Different sets meaning, do they have different elements in them? Does one set have at least an extra element than the other? Well, no, because both sets have 0, 2, 4, 6, 8. Neither set has an extra element than the other, so it fails criteria 2 because they're actually the same set. Remember, we don't want the same set to be proper. That's what proper means. So because we wanted different sets, but it failed that. We got the same set. It's not proper subset. So the set of 0, 2, 4, 6, 8 is not a proper subset of 8, 0, 6, 2, 4 because they're really the same exact set. So the only one that worked out was it's a normal subset. So that's the only one I can select as the final answer. It's not proper. It's not a proper subset because they're the same exact set. It failed criteria 2. All right, let's try a few more. Looking at C, the set of X such that X is a man. On the right, the set of X such that X is a person. So looking at what comes after the bar for this set builder notation, they're talking about all the men in the set on the left. And then the set on the right, they're just talking about all people in general. So to be a subset means that all men are people. All men are contained in the people set. That's true. So all men are people. So at the very least, it's a normal subset. Now let's see if we can take it a step further and say it's a proper subset. So we got to go over to our criteria. Is it a normal subset? Yes. It passes criteria 1. We just said a minute ago it's a normal subset. Criteria 2, are they different sets? Yes. Now it passes criteria 2 because the set on the right is larger. All the people would be men and women combined. So the sets are different in that the set on the right has more elements in it. It's a larger set. It has extra elements. So they're not the same exact set, in other words, when we say different. So it passes criteria 1, criteria 2. So this is both proper subset and a normal subset. It's proper because it's a subset and the sets are different. Looking at D, let me actually rewrite this criteria. It's getting a little bit messy here. So I'm going to just rewrite this since I have all these check marks and arrows all over the place. So remember, to be a proper, actually let's use a different color. Okay, there we go. So to be a proper subset, we always got to see, is it a normal subset? Question mark. And then are they different sets? Are the two sets we're comparing not the same? All right, there we go. So looking at D, the set of X such that X is an element of the natural numbers and 5 is less than X is less than 12. And then the set on the right, we got the set of X such that X is an element of the natural numbers and 2 is less than or equal to X is less than or equal to 11. I always like to translate, whenever I see that bar for set builder notation, translate what that really means in my head before I answer this question. So let's translate what these sets are actually referring to first. So on the left, we have that capital N. Remember, that means natural numbers. Those are the positive whole numbers that are in between. It says 5 is less than X is less than 12. So they're in between 5 and 12. I do not see any equals bars, so I'm not going to include 5 or 12. There are no equals bars below the less thans. So everything's strictly in between 5 and 12. So that would be 6, 7, 8, 9, 10, and 11 is really what the set on the left is referring to. I know you wish they would just say that. Unfortunately, they don't. Okay, now let's look at the other set. So it's another capital N. So it's all those positive whole numbers again. And the numbers in between 2 and 11, I do see an equals bar beside the 2, so we're going to include 2. I also see an equals bar touching the 11, so I'm going to also include 11. So these are all the numbers in between and including 2 through 11. It's like 2, 3, 4, dot, 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 all the way up to 11. All right, so now let's go back to the original question. Let's start with normal subset. So, are all the numbers on the left somewhere in the set on the right? Yes, 6 through 11, those numbers are somewhere in the set on the right, because remember the set on the right are the numbers 2 through 11. So that is true. It is, at the very least, a nice normal subset. 6 through 11, all those numbers are somewhere inside the set on the right. Okay, can we take it a step further? Let's check the harder one and say it's not just a subset, but it's a proper subset. Well, let's check our criteria. Was it a normal subset? Yes. 6 through 11, those numbers are in the set on the right. Are these different sets? Yes, it passes criteria too. The set on the right has more elements. It has 2 through 5 in it, which the set on the left does not. So they're not the same exact set. Yay. So it's a subset where they're different sets, so it's also a proper subset. So D is both a subset and a proper subset. Let's try one more. Example 4, same directions. Determine whether it's a subset, a proper subset, both or neither. And I just have A is all I could fit in on this slide. But we have the set of F-I-N, kind of looks like fin. Is that a subset, yes or no, to the set of F-I-N-K? Well, yes, it's a subset because all the letters you see on the right as well. So F, yep, you see that inside the set on the right. You see I, you see N. So it's a normal subset. Okay, let's check our criteria to see if we can take it a step further and say it's also a proper subset. So, criteria 1, was it a subset? Well, we just said yes. Criteria 2, are these different sets? Yes, the set on the right has a K in it, whereas the set does not. So they're not the same set. Yay, they're different sets. So it also passes criteria 2, so it's also a proper subset. So the answer is both. It's a subset and it's a proper subset. Let's try just one more. Same directions. This is still example 3. Determine if it's a subset, proper subset, both, or neither. On the set on the left, we have the set of Mercury, Venus, Earth. On the right, we have the set of Venus, Earth, Mars, Jupiter. So first, we're going to see if it's a normal subset with the equals bar underneath the squished C symbol. So to see if it's a normal subset, all the items, objects on the left better be somewhere on the right. But when I look for Mercury, Mercury is nowhere to be found on the set on the right. So right away, I see it's not a subset because Mercury is nowhere to be found in the other set. Now let's try proper subset. Keep in mind for proper subset, we have 2 criteria to check. We first have to see if it's a subset, obviously, to begin with. And then they have to be different sets with different elements in them. At least one different element in one of the sets. So they're not the same exact sets. Well, it passes criteria 2 right away. They are different sets because the first set has Mercury in it. The second set does not. The second set has Mars, Jupiter in it. The first set does not. So it passes criteria 2. However, it failed criteria 1. It was not a subset to begin with. So this is not a proper subset either. So it was not a subset. It was not a proper subset. So neither one of them works as the final answer. So my point here with this example is when you're checking for proper subset, it has to pass both criteria. If it fails at either criteria, you're going to say, nope, it is not a proper subset. For any word problems near the end of the section 2.2 homework, you would use these formulas up here. And all these formulas do is they count up how many subsets and how many proper subsets would be generated from the set that the problem gives to you. So for number of subsets, let's start with that one. The number of subsets is the number of distinct subsets of a set with n elements is 2 to the n power. So notice that n is an exponent. And if you wanted to figure out how many proper subsets you could create, it's the same formula. You see that 2 to the n power again, and then you just subtract 1. I promise it's not as bad as it looks. So remember that n, the exponent, represents the number of elements in the set that they give to you. And you might want to have some sort of a calculator nearby for when it's a larger answer. And you want to know where the exponent button is located on your calculator. For most calculators, it's the up arrow, or we also call it the caret. For at least the graphing calculator, that's the button to look for. So looking at example 5, we have 3 parts. So part A, determine the number of subsets for the set with TAB. So it wants just the number of subsets. So we said that's 2 to the n power is the formula to use. Remember, n represents the number of elements. Little n is always number of something. You're always counting when you see that little n. And here we have, let's see, we have T, A, B. So in this case, there are 3 elements, T, A, B, in the original set. So you're going to plug in 3 into the n in the formula, which is the exponent. Plug it in, plug it in. So the base is always 2, base meaning the number that holds up the exponent. So the base is always 2 in this formula, and we're plugging in 3 into the n exponent. So we're going to do 2 to the 3rd power, or 2 times itself 3 times. And you can either do it in your head or on the calculator, but you do get 8. So there are 8 total subsets we could create from the set with TAB. To make the calculator do it, on the graphing calculator, I would put the 2 in first. My caret, my exponent, is right here. It's right above the division key, so I hit the up arrow. And then the exponent was 3. Use the right arrow key to move your cursor back down to ground level. And we use enter for equals, which is on the bottom right corner. And voila, there's that 8 for the final answer. You can probably guess what's coming next. Part B says to then list all the distinct subsets for the set with TAB. So we know that there are 8 of them. Let's list all 8 in any order. So before I forget, I'm going to list the empty set. Remember, the empty set is a subset of any set on the planet. So I'm going to use the empty set symbol, or you have the curvy brackets with just nothing but air in them. All right, so 1 down, 7 to go. Also, subsets is we could look at 1 letter at a time. So the set with just the T in it. Yes, I'm making a curvy T there so that it doesn't look like a plus symbol, but that's my T. And then we could look at just the set with just the letter A in it. And we could also look at the set with just the letter B in it. Yes, these are all sets, so I do unfortunately need those curvy brackets around all my answers. So we could have the empty set, which has no elements in it. We could look at 1 element at a time. TAB, you could probably guess what I'm going to say next. Now we could look at 2 letters at a time. So T with A. And by the way, the order of those elements, remember, does not matter. So if you're saying AT, that's the same as TA. I don't want to double count that set. So TA, AT is referring to the same set. You could also pair up T with B. Or again, if you're saying BT, that's the same as TB. Or I could pair up A with B, or BA, same thing. They would not repeat it if this were a multiple choice question in the homework. They would just list each of these sets once. And then finally, the 8th set is the whole set back again. So that was TAB, looks like tab. So we can see what this formula did. It literally just counted all the subsets we could create, and then in B we listed all 8 of them. And then finally C, how many of these subsets you listed in part B are also proper subsets? Remember, proper means different or not the same set. So if we don't want the same set as the original set was TAB. If I get rid of set number 8, because we want different sets, we can see that there are 7 subsets remaining. So we get rid of the original set back again, and then all those are proper. Or you can just use the formula right up here, where we take 2 to the n power again, but then we subtract 1 from that, will give us the number of proper subsets. We still have 3 elements, TAB, so n, the exponent, is still going to be 3 to plug in. So that's 2 to the 3rd power, but now it's minus 1. We already said 2 to the 3rd power is 8 minus 1. So there are 7 proper subsets that can be created from the set with TAB in it. And the empty set is a proper subset again as well.